Now, there is a receptor here. Okay? I mentioned that there is what neurotransmitters would cause an increase in cyclic AMP, dopamine, epinephrine, norepinephrine. Good. So catecholamines in general. So the catecholamines are released from the presynaptic, go onto the receptor of the postsynaptic. So this is not the postsynaptic neuron. This is the postsynaptic neuron. Okay? Now, once it hits this receptor, okay, an enzyme called adenylyl cyclase, and I'm sure this is very familiar to you because this is biochem. Okay? Adenylyl cyclase, what does it form? And adenylyl cyclase is the one responsible for converting ATP to cyclic AMP. So this is the one that converts ATP. How does this happen? Are you all still with me? Okay, this is, remember ATP, how many phosphates? 3, right? This is ATP. Okay? Yeah, okay, triphosphate. Now, adenylyl cyclase cleaves ATP in this chain over here. Okay, so adenylyl cyclase, okay, will cleave ATP there. What is formed? AMP, okay, monophosphate, right? And 2 PPs, or 2-phosphate. PP sounds a bit, it sounds a bit rude. Okay, this is called. Which one? Yes. What is it? This is called pyrophosphate. Okay. Okay. So the 2 phosphates separated from ATP is called pyrophosphate. Okay, now, an increase in cyclic AMP is associated with an increase in the permeability of the cell membrane of the postsynaptic cell to what ion? Sodium. So there's an increase in the permeability of the postsynaptic cell. Once you have an increase in CAMP, there's an increase in permeability of the membrane to sodium. And once sodium starts rushing in, what happens? Depolarization occurs. And if the depolarization is strong enough, an action potential will start. That is the reason why the catecholamines are excitatory. Because they always cause the opening of or the permeability of sodium to increase in the membrane due to cyclic AMP. But if you've ever been tired, and you all look like you're tired now. If you've ever been tired, you always know that this is a very short-lived process. Because another enzyme will break down your cyclic AMP. Does anyone remember what this enzyme that breaks it down, what's it called? No one remembers. Okay, it is phosphodiesterase. Okay? Phosphodiesterase is the enzyme that breaks down CAMP. That's the reason why any excitatory reactions are usually short-lived. How short-lived? 10 to 2 minutes. Now, what happens here? There are actually 2 ways to continue the excitation. The first way is to give a mimetic drug, something that mimics catecholamines. What drug do you know mimics or looks or has the same action? as catecholamines. Caffeine is not. No. Caffeine isn't. It's actually a legal drug. Amphetamines. Okay? Amphetamines are structurally similar to epinephrine. Very, very structurally similar. But, okay? But, note this about amphetamines. Remember that in synaptic cleft, remember I told you that there's always an enzyme that breaks down the neurotransmitter? It's the same with epinephrine and the catecholamines. There are enzymes that break them down. Do you know what the name of the enzyme is? The enzyme that breaks down catecholamines is MAO, monoamine oxidase. That is the enzyme that breaks down your catecholamines. That's why in Parkinson's, remember I told you about Parkinson's? Okay? What is the mnemonic for the drugs? It's Balsa. Yeah, and Catecholamine is a MAO inhibitor. Why? Because remember, there's a very, very low dopamine level in this patient. You want, because there are low dopamine levels in the patient, you don't want MAO to keep degrading that small amount of dopamine there. So what do? You give an inhibitor so it does not degrade the small amount of dopamine left in the system. Okay? So this is the inhibitory, this is the degradation enzyme for catecholamines. Now, how do you prolong this effect? And you might be interested in this because everyone's always wanting to wake up. The only way you wake up is if you get enough sleep. Okay? Trust me, I know. So catecholamines. So you get a drug that mimics or has actions like catecholamines, which is amphetamine. It is almost structurally the same as epinephrine. But why is it that people on amphetamines, okay, we all know it as methamphetamine, shabu, why do these people, when they have methamphetamine, they can sustain that excitability for hours? Very good. Because MAO cannot break it down immediately. It will eventually break it down. But MAO was designed naturally to break down natural catecholamines. So you put in a synthetic catecholamines, it kind of gets confused. And it takes longer to break it down. And that's the reason why. So remember, if you have ketamine in the system, what will happen? Then you will have increased adenyl cyclase, increased conversion of your ATP to cyclic AMP. So even if there's phosphodiesterase, as long as this process keeps going, you are excited, you are liberated. Now, you all know amphetamine is illegal. Okay? It's illegal. If you are on amphetamines now, I urge you to stop. Okay? It's associated with long-term structural changes in the brain as well. Neuroplasticity, remember. So what's the next best thing? Especially when you wake up in the morning. All of you, me, wake up in the morning, you all look like the zombies in, what's that? The Walking Dead, yeah. You are the Walking Dead in the morning. Right? You're all walking dead. You want something to wake you up. You don't get that rush of excitement right away, right? Because remember what I tell you? Why is it difficult to wake up? Because we have serotonin in our system. It's inhibiting you. So when you wake up, you have that feeling, oh, I still want to go sleep. You have that feeling you're weak. That's because of serotonin. And the only way to get yourself perked up for the day is if you get catecholamines into your system. So what do? What is the thing that you drink in the morning that is associated with